Welcome to the DIY Honda Garage channel. The DTC B1241, also known as DTC Indicator 59, signifies an issue in the blower motor circuit of the Honda Civic models produced between 2011 and 2015. The blower motor is crucial for the vehicle's heating and air conditioning system as it circulates air through the cabin. This component is typically located behind the dashboard, near the firewall, and is powered by electrical signals received through its circuit. The control module, or climate control unit, regulates the blower motor's operation by sending voltage as required. Identifying this DTC is essential, as it may impact a driver's comfort and the ability to maintain vehicle climate efficiently, especially under varied weather conditions. Understanding the role and operation of the blower motor and its associated circuitry is the first step in addressing this diagnostic trouble code. The DTC B1241 indicates a fault in the blower motor circuit. The blower motor is responsible for moving air through the vehicle's HVAC, heating, ventilation, and air conditioning system. In Honda Civic models from 2011 to 2015, this motor is positioned behind the dashboard, close to the firewall, where it can effectively circulate air into the cabin. The climate control unit plays a pivotal role, sending voltage to the blower motor based on user settings. A malfunction in this circuit may hinder the proper functioning of the AC and heating system, potentially impacting passenger comfort. Regular functioning of the blower motor is necessary for defrosting windows and maintaining a pleasant driving environment. Continuing with further checks is crucial to confirm and rectify this issue. Multiple factors could contribute to triggering DTC B1241. Electrical connection issues, such as loose wires or corrosion, may disrupt the current flow, leading to a malfunction in the blower motor. Additionally, the condition of the fuses linked to the blower motor circuit must be examined, as blown fuses can interrupt electrical flow. A faulty blower motor itself is also a likely culprit, as wear and age can diminish its operational efficiency. Similarly, a defective power transistor, which regulates the current going to the blower motor, can lead to this error code. Lastly, there's the possibility that the relays responsible for controlling the current to these components may fail, necessitating thorough checks of all these potential causes. Recognizing the symptoms associated with DTC B1241 is crucial for prompt diagnosis. A primary indication is the blower motor's failure to operate, which can instantly affect air circulation within the cabin. Drivers may also notice intermittent air circulation, where the blower functions sporadically or only at certain speeds. Temperature control can become inconsistent, making it challenging to maintain a comfortable environment within the vehicle. Further, the HVAC control system may display no response, rendering it ineffective. Most importantly, the presence of the DTC B1241, indicated by a diagnostic scan, emphasizes that further investigation and repair are required to restore normal functioning and passenger comfort. The first troubleshooting step for DTC B1241 begins by clearing the DTC using the HDS, which stands for Honda Diagnostic System. This tool allows technicians to reset the error codes and evaluate if the issue is a persistent fault or an intermittent problem. After clearing, turn the ignition switch to the lock position and then back to the on position to reset the vehicle's systems. Following this, perform a self-diagnostic test with the HDS or the climate control unit to re-evaluate the blower motor circuit. After the diagnostic is complete, check again for any existing DTCs, specifically looking for indicator B1241. If this code reappears, it confirms that a persistent problem exists, leading to the next steps in the troubleshooting process. In the second troubleshooting step, Begin by turning the ignition switch to the lock position, ensuring the vehicle's systems are inactive before inspection. This step emphasizes checking the specific fuses that govern the blower motor's operation. Fuse number A2-8, rated at 40A, located in the underhood fuse relay box, and fuse number B22, rated at 7.5A, located in the under-dash fuse relay box. Inspect these fuses meticulously to determine if they are intact or have blown, as this could disable the blower motor circuit entirely. If at least one of the fuses is faulty, replace it, then recheck the operation of the blower. Should the fuses blow again, it's critical to investigate further for possible short circuits in the wiring associated with these fuses. This step ensures that power is being appropriately supplied from the electrical system to the blower motor circuit. The third step involves checking the power circuit reaching the blower motor. First, disconnect the blower motor's 2P connector, which is essential for safely performing the voltage tests. Next, turn the ignition switch to the on position, 2, to provide power to the electrical systems. Using a multimeter, measure the voltage between specific test points on the blower motor connector. Test point 1 at the blower motor 2P connector, number 2, white, and test point 2 to the vehicle's body ground. The expectation here is to see battery voltage, which indicates that power is being delivered to the blower motor circuit correctly. If voltage is present, it implies that the power side of the circuit is functioning and directs to the next troubleshooting step. Conversely, if there is no voltage, further investigation is necessary at step 10, which will explore other potential failures within the circuit. For the fourth troubleshooting step, reconnect the previously disconnected blower 2P connector to ensure the motor circuit is complete again. Following this, create a direct path by connecting terminals A and B with a jumper wire. Terminal A connects to blower motor 2P connector number 1, green, while terminal B connects to body ground. By doing this, you're bypassing the climate control unit and directly supplying ground to the blower motor. Now, turn the ignition switch to the on position 2 to assess whether the blower motor will operate under these controlled conditions. If the blower motor runs, it indicates that the issue lies upstream in the circuit. You'll proceed to the next troubleshooting step. However, if the blower fails to operate, it suggests that the blower motor itself is likely defective and may need replacement. The fifth troubleshooting step focuses on verifying the ground GND side integrity within the system. Start by turning the ignition switch to the lock position to ensure the circuit is inactive before proceeding. Next, disconnect the jumper wire used in the previous step and then remove the power transistor's 4P connector to focus on the GND continuity test. Check for continuity between test points. Point 1 at the power transistor connector number 3, blank, and point 2 connected to the body ground. Achieving continuity confirms that the GND wire is intact and functioning properly, allowing for the current flow necessary for the blower motor operation. If continuity is present, you can confidently move to the next step, whereas a lack of continuity necessitates repairing an open circuit in the wire, with further checks for poor ground at the G401 point being vital in this diagnosis. In the sixth troubleshooting step, you need to verify the integrity of the BLWM line. This is done by connecting terminals A and B with a jumper wire. Terminal A will connect to the power transistor's 4P connector number 3, black, while terminal B will connect to the power transistor's 4P connector number 4, green. Once these connections are established, turn the ignition to the on position, I, to functionally test if the blower motor runs at high speed. This test checks the circuit condition under a demanding scenario, providing clues about the wiring and modules involved. If the blower operates at high speed, it indicates that the wiring in the BLWM line is intact. Conversely, if it fails to operate, it signals a likely issue within the wiring between the power transistor and the blower motor, requiring repair or replacement. The seventh troubleshooting step requires checking for any shorts in the wires leading to the climate control unit. First, ensure the jumper wire from the previous step is disconnected. Next, focus on the 32P connector of the climate control unit and individually check for continuity at two specific points associated with blower operating circuits. Blower G yellow at point 12 and blower V blue at point 13. Testing continuity of each wire back to the body ground will reveal if there are any shorts along these lines. If continuity is confirmed without any shorts, it indicates both wires are functional and leads you to step 8. However, if a short is detected, it necessitates repairs in the wire between the climate control unit and the power transistor to restore appropriate operation. In the 8th troubleshooting step, you will verify the integrity of the wiring between the climate control unit and the power transistor. This involves checking continuity between the wires corresponding to the blower G/BLWG and blower V/BLWV lines. Make sure to set the ignition to the lock position to ensure safety during the checks. Measure continuity between test point 1, blower G, at the climate control unit's connector and test point 2 at the power transistor's connector for both wire types. Achieving continuity confirms that the wiring is clear of breaks. In case there are interruptions in continuity, corresponding repairs are necessary to restore function. Once confirmed, you'll proceed to the next troubleshooting step, enhancing the system's reliability. Step 9 focuses on assessing the power transistor's functionality after re-establishing the connection to the climate control unit. At this stage, the power transistor is critical as it regulates voltage to the blower motor based on the settings configured by the driver. By testing the power transistor, you can ascertain if it's operational. If the transistor passes testing, it indicates that the malfunction may reside within the climate control unit itself. In that case, replacement of the control unit becomes necessary to restore normal functioning. However, if the transistor is found to be defective, not only should it be replaced, but also the blower motor should be examined for potential damage, as it could be affected by prior electrical issues. This step ensures that you address both components to prevent recurring faults. The 10th step in troubleshooting DTC B1241 zeroes in on the blower motor relay's functionality. Start by turning the ignition switch to the lock position to ensure safe disconnection of components. Next, locate and remove the blower motor relay from the underhood fuse/relay box, as this relay is essential for controlling power to the blower motor during operation. Testing the relay will determine its operational status. If it fails to engage, the relay itself is likely at fault. Replacing a defective relay is critical, as it ensures that the blower motor receives the appropriate electrical signals required for functioning. Confirming the relay's integrity is a significant step in securing the blower motor's reliable performance within the vehicle's HVAC system. In step 11, the focus shifts to the +B HTR/MTR line, responsible for providing power to various components, including the blower motor. To start, measure the voltage between specified test points, ensuring that the blower motor 2P connector and the blower motor relay are disconnected to avoid erroneous readings. The goal is to ensure that there is battery voltage present at this test point. If the voltage is confirmed, the +B HTR/MTR wiring is deemed functional. However, if no voltage is detected, it signals an open in the wiring. that necessitates replacement of the underhood fuse relay box where this wire connects. Verifying and ensuring that power is reaching all necessary components is essential for resolving the DTC and ensuring overall system operation. The 12th step in addressing DTC B1241 includes testing the IG2 AC line for proper voltage supply. First, activate the ignition switch to the on position. 2. To power the electrical systems. Measure the voltage between specific test points, ensuring access to the blower motor relay socket and performing the test with the blower motor connector still disconnected. Confirming that battery voltage is present indicates that there are no issues with the wiring leading to the blower motor. Conversely, if battery voltage is absent, it points to an open circuit between the number B22 7.5 amps fuse in the under-dash fuse relay box and the blower motor relay. Assuring this wire's integrity is crucial to maintain the system's operability. Lastly, the 13th troubleshooting step focuses on ensuring proper continuity within the ground GND line. Start by turning the ignition switch to the lock position. Following this, check for continuity between test points. Point 1 at the blower motor relay 5P socket number 5, black, and point 2 connected to the body ground. Establishing continuity indicates that the ground connection is secure and that the blower motor circuit is complete. Absence of continuity denotes an open in the wire that needs to be repaired to ensure the blower motor receives the necessary ground for operation. Additionally, where issues are not traced back to the wiring, a check for poor ground contact at the designated ground point, G401, should be performed. Ensuring proper ground connection is vital to complete the electrical circuit for optimal function. Final repair verification for DTC B1241 is a critical process to ensure that all fixes have effectively addressed the underlying issues. Start by rechecking for any DTCs through the HDS, verifying that DTC B1241 does not reappear, which would mean the repair process was successful. Next, confirm the blower motor's operation. It should respond correctly across all settings of the climate control system, effectively providing adequate airflow as expected. The operation of the climate control system overall should be normal, regulating temperatures effectively as designed. Additionally, ensure that all related fuses and the relay are functioning properly to prevent recurrence of the issue. Completing these checks assists in validating that the repairs made resolved the original problem. Preventive maintenance is paramount in avoiding future occurrences of DTC B1241. Regularly inspecting the fuses associated with the blower motor circuit is necessary to catch potential issues before they escalate to a failure. Ensuring that electrical connections are clean and corrosion-free can help maintain optimal current flow throughout the circuit. Additionally, keeping the blower motor clear of debris and dirt will enhance its efficiency and longevity, preventing unnecessary wear and tear. Routine testing of the relay can ensure that it is functioning properly and interfacing correctly with the climate control unit and blower motor. By taking these preventive measures, you not only enhance the system's reliability, but also contribute to improved passenger comfort. In conclusion, DTC B1241 indicates a significant problem within the blower motor circuit that requires thorough troubleshooting to identify and resolve. Understanding the components involved and their interconnections is vital for an effective diagnosis. Each step followed during troubleshooting aids in isolating the fault to ensure proper repair is achieved. Regular maintenance practices can prevent the recurrence of this issue, fostering reliability in the vehicle's HVAC system. Finally, conducting operational checks post-repair ensures that the blower motor and related components function as intended, delivering comfort and safety while driving. A proactive approach in maintenance and verification is essential for long-term operational success. Please like and subscribe to the channel. See you next time.